In this lesson, we'll look at integrating 1 over x. So these are integrals that the value has a natural log in it. In the previous lesson, we saw how the derivative of natural log is 1 over x. We also saw in the graph that when we had a graph of natural log, it was like this, and when we had the graph of the derivative, it was like this. So we see that if we write 1 over x, it has this part of the graph, but x is positive, and x is positive because we're only going to have positive values there. So then when we look at this equation, this differential equation, we'll write it like this, move the dx over, and integrate. We have to be careful that we don't just say that the antiderivative is ln x, because this is saying x could be positive or negative, but we know that x is positive, so we'll make sure that we do that. And if we have it's really a simple rule, so there's not much to do unless we start substituting. So everything's just going to be really basic like this. So to get something more interesting, we have to do integrals that require substitution. And here we see that there's something with a variable in the denominator. It looks like that. So we will let u be the denominator. U, x, u evaluated at a. Here's our organization for substitution. So we'll let u equal 2x plus 1. du is 2 dx. du over 2 equals dx. We won't need this, and we don't do this unless there are limits, unless it's a definite integral. dx is du over 2. So we can just take the constants out, and antiderivative of 1 over u is natural log of u. Absolute value, substitute back. Alright, pause the video and try that one. So the derivative of 3x is 3 dx. The derivative of 1 is 0. So we just have 3 dx. And here we can simplify 6 over 3 is 2, take it outside, integral 1 over u du, and that is 2 natural log u plus c, 2 natural log, and u is 3x minus 1 plus c. Here we'll just substitute and hope that the x cancels. So we'll start with u equaling the denominator. And we take the derivative of each term. Here's the derivative. We will isolate dx. U evaluated at the limits, so u evaluated at 2, u evaluated at 1. If we put a 2 in there, we'll have 8 plus 12 is 20. Put 1 here, we'll have 1 plus 6 is 7. So instead of integrating from 1 to 2, we'll go from 7 to 20. And that stays there, but now we have u in the denominator, and dx is du over 3x squared plus 6. So here we can factor out a 3, and then what's left will cancel up there. So then we have a 1/3 factor, and the 1/3 comes out. 1 over u is natural log of u from 7 to 20. So natural log 20 minus natural log 7. We don't have to write absolute value because they're already positive. And we could rewrite it as 1/3 natural log 20 over 7. All right, pause the video and try that one. So let u equal the denominator. And if we put 3 here, we have 9 plus 24, 33. And we put a 2 here, 4 plus 16 is 20. Integral from 20 to 33. And that'll be 1/2 natural log of u from 20 to 33, 1/2 natural log 33 minus natural log 20. (33 over 20). Right. So every time we see rationals, we could try just substituting u equals the denominator, but in this case, we need to do something else before that happens. So if there's usually if there's a monomial in the denominator, you want to, and not a monomial in the numerator, we want to separate that as x over x squared, 2 over x squared, so that now we can reduce this, and this is not even involving a natural log. So we'll rewrite that 1 over x, so that reduces to 1 over x. Let's just separate them. And we could write that as 2x to the negative 2. So we're going to use the power rule there, and then we can just use a natural log there. So we're going to add and divide ln3 minus ln2. Let's simplify that to be negative. I'll take the negative 2 outside, and then it's just a 1 over x. So this is 1 over x, this makes a negative 2, and I put it in front. Plus 2, 1/3 minus 1/2. Uh, 2 over 6 minus 3 over 6. So it'll be a negative 1/6 times 2, and that's negative 1/3. Okay, pause the video and try that one. And we don't have to separate it. If required substitution, then we should separate, but here you could have left it like one integral. So we'll get 25 over 2, substitute the 1, and here we have natural log 5 minus natural log 1. And that gives us 24 over 2, that's 12. Natural log 5, and that's 0. So we're all done. And that's the end of the lesson.